Hi students, in this video we see what is DTFT, why we need it, and what is the formula, right? So I give a brief introduction, not in-depth introduction. Okay, so what is DTFT? It is nothing but discrete time Fourier transform. Okay, so if you want to analyze a discrete time signal, right? So discrete time signal analysis is carried out by using DTFT, right? What do you mean by discrete time signal analysis? If you want to find the frequency of discrete time signal, right? Frequency of discrete time signal, you use discrete time Fourier transform, right? That is the main purpose of studying discrete time Fourier transform. So if you have a signal x of n, the DTFT of the signal is given by x of e power j omega. Right? This is the discrete time Fourier transform. So you see that is equal to DTFT of x of n. Right? So you see here it converts n is time, omega is frequency. So time domain into frequency domain. It is discrete time, so I can call time instant. Right? It is digital frequency. So what is the formula to find DTFT? DTFT of x of n is x of e power j. DTFT of x of n is represented as x of e power j omega, that is given by summation n goes to minus infinity to plus infinity x of n e power minus j omega n. So what happens? You give input as n, that is converted into omega. Fine. So this is what DTFT about. Okay. What is the inverse DTFT formula? IDTFT is, if you give x of e power j omega, you will get x of n. So x of n will be equal to, so 1 by 2 pi minus pi 2 plus pi x of e power j omega into e power j omega n d omega. So here you see I give input as omega, that is frequency domain signal. What we get is time domain. So it converts omega to n, IDTFT. Okay, so the another thing is why we are going from minus pi to plus pi. That is another important question. See, the integration varies with respect to integral with respect to omega, which varies from minus pi to plus pi. Omega varies from minus pi to plus pi. Why? Because we know digital frequency range is minus pi to plus pi. Digital frequency omega ranges from minus pi to plus pi only, that is 2 pi. After that it will repeat. So this is very important. So don't go for minus infinity to plus infinity, you go from minus pi to plus pi. And another thing is, you know, x of e power j omega is given by x of e power j omega plus 2 pi. Why? Omega is 2 pi. What is the reason? You see x of e power j omega plus 2 pi is equal to x of e power j omega into x of e power j 2 pi. Fine. So if I add, now e power j 2 pi is what? E power j 2 pi is cos 2 pi plus j sin 2 pi. Sin 2 pi is 0, cos 2 pi is 1. So that is equal to e power j omega into 1. So x of e power j omega. So x of e power j omega is equal to x of e power j omega plus 2 pi. So x of e power j omega is spectrum of x of n. I can call it is a spectrum of x of n. That is what x of e power j omega. That is equal to, you see it is repeating after every 2 pi. If you substitute 2 pi, again I get j omega. If you substitute 4 pi also, I will get the same thing. So the spectrum of e power j omega is periodic with period 2 pi. If I put 2 pi, again I get the original. If I put 4 pi also, I will get the same answer, x of e power j omega. So 2 pi, 4 pi, 6 pi, everything it will repeat. So DTFT spectrum is periodic in nature. Right? That is very, very important point. Okay. Next thing what we have to know is existence of DTFT. Condition for existence of DTFT. Condition for existence of DTFT. How can we do? So we know x of e power j omega. DTFT of x of n is x of e power j omega, which varies from minus infinity to infinity. X of n e power j omega n. Right? So I want DTFT to be existing. That means it must be having finite value. So I take modulus. So left side mod x of e power j omega must be less than infinity. Then only DTFT exists. It is finite. That is spectrum is finite, not infinite. It is less than infinity. That is x of e power j omega, not infinity. That means it is finite. So this is the condition for existence. So if mod x of e power j omega should be less than infinity, means I have to take right side also modulus. This implies mod n goes to minus infinity plus infinity, x of n e power minus j omega n must be less than infinity. Yes or no? So what is the modulus of e power j omega n? Modulus of e power j omega n or plus j omega n minus j omega n, it is equal to 1 because cos omega n plus j sin omega n. What is the magnitude? Magnitude of a plus ib is a squared plus b squared. So cos squared omega plus sin squared omega, it is 1. So whatever be this factor, e power j is 1. So mod e power j is 1, mod e power j is 1. So that is equal to minus infinity plus infinity. I bring modulus inside, x of n should be less than infinity. So this is the condition for existence of DTFT. So what is the condition? X of n should be absolutely summable. That means given input sequence x of n is absolutely, where is absolute is there, this modulus is absolute value. Summable, we must be able to sum it up. Right? If it is infinity, it is not able to sum it up. So this is the condition for existence of DTFT. So if you are able to sum your given input sequence, then you can find DTFT. Otherwise, you cannot find your DTFT. Thank you.